Have you ever stopped to think and wonder, where does the information come from that gets generated by the large language model? So in the last example, we prompted the large language model with once upon a time, and it generated there was a magic castle. Where did that magic castle come from? Well, the answer in that case was, well, it was my head, but the answer in that case, if it was actually a large language model that was doing that, is that it would have come from the pre-training of that model. So during the pre-training stage is when the model gets created and generated for the first time. And usually with a large language model, they'll take all of the data they can find on the internet, so the complete works of Shakespeare, all of Wikipedia, everything that they can find on Stack Overflow, and they will use it to train the model to get an understanding of natural language. And so in this case, that's where that information comes from. But what about if we want the large language model to work on our data, something that we have that the model's not seen during its pre-training? Well, that's where in-context learning comes in, and in-context learning is a type of prompt engineering. And if there's one thing that you should drill down on and get across in the whole area of generative AI, I think it's prompt engineering, because it really ties everything together. So let's take a look at in-context learning in a bit more detail. We're going to use the example of summarization, so text summarization. We have some text, say for example the minutes of a meeting, and we want the large language model to provide a summary of those minutes. We can absolutely do that. And so what we might do is we might generate or engineer a prompt that says, summarize this text, and then we can provide the minutes of the meeting inside the prompt as part of the prompt. So we're engineering our prompt. And we can pass all of that to the large language model and see what it'll do. Now, with large language models, where we're talking about hundreds of billions of parameters, they're actually pretty good at this. And this is called zero-shot prompting, because we're not giving it anything other than just the information it needs, and we ask it to please provide the completion, which in this case, hopefully, is the summarization of the minutes of our meeting. But there's a little problem with that. We weren't able to explain in any more detail to the large language model how we wanted the summary to be presented. Did we want a very, very concise summary or a slightly longer one? Did we want the language to be very formal or kind of informal? Did we want to zero in on who was present in the meeting? All of these different things that we haven't explained to the large language model. And so we can provide more information to the large language model in the command or the prompt to do the summarization. And we can do that by providing an example. Imagine for a moment that you have a new intern at your organization and they have arrived and you say to them, please summarize the minutes of this meeting. And they might be very, very keen and very capable, and they take all of those minutes, they diligently go away and write up a summary and provide it to you. And you say, well, actually, that's not quite what I was after. Now, what would a reasonable response for that intern be at that point, apart from go and summarize your own minutes? They might say to you, well, can you give me an example? And that's exactly what we can do with a large language model, with something that we call one-shot inference. And one-shot inference, rather than just giving it the text that we want to summarize, we can actually give it an example of some text and an example summary inside of the prompt. And then we can append the please summarize this text again and provide the actual text that we want the model to summarize. So by providing an example to the large language model, it has the ability to be able to see the kind of summary that we want and understand a little bit more about the task that we're asking it to do. And so that is one-shot inference. Now, it could be that maybe the model is kind of a bit smaller and a little bit less capable, or maybe the specifics of what we want the model to do are kind of complex. Maybe we need to give it more than one example, and so we can do that with few-shot inference. And as you can see, we can start to build up a prompt which is really quite long with many examples of what we want. Now, this is an example where we're doing summarization of text. Imagine that we were doing sentiment analysis, or we were looking at product reviews and we want to know if they were positive or negative or neutral. In that case, where we've got a multi-class classification problem, it's probably a good idea to have few-shot inference, where we give the model examples of what we think is positive, about what we think is negative, about what we think is neutral. And this, in-context learning, can get you a long way with a capable large language model and some creative use of prompt engineering like this. You can get the large language model to produce what you want. But there is one drawback. As you can see, the more information that you add into the prompt, the larger the prompt. And if you remember the context window that we looked at in the previous lesson, well, the context window is of a fixed size. There is a limit to the amount of information we can put into the model. And you'll also remember that the context window contains the completion as we're generating the next tokens as well. So if your large language model is still not performing after you've provided many examples, and you're getting to the point where you just can't fit any more examples in, well, at that point, you have to start thinking about fine-tuning your large language model. And that's what we're going to take a look at in the next video.